Hello ladies and gentlemen, welcome back. This video is for students who are in Algebra 1 Goal 3. You can see that we are almost done with video tutorials for the goal, and so far every single video has been averaging just about 15 minutes because even when I'm doing 3 or 4 topics in a video, they're going by really fast because the work itself in Goal 3 is not that hard. Goal 4 is already complete, as is Goal 5, so from here you should be able to move through the following chapters with infinitely more ease if I'm not immediately available as we continue with this distance learning shtick. So these last two families of topics, like every single one of them is a DSA question. So word problem, that's a DSA question. Writing a direct variation, that's a DSA question. Identifying from ordered pairs, I believe, is a DSA question, etc., etc., etc. So we want to get comfortable with those first, especially since one of the topics, I already hear a couple of people losing their minds because they see the phrase word problem in there. But let me build you up to that first. When we talk about direct variation, what we're actually talking about is something from the graphs that we were doing before. In an earlier video, we were talking about y equals mx plus b, where b is your y-intercept, and m is your slope. That's what we were talking about in a different video. Well, direct variation is just that. Y equals mx, only instead of calling it m, because they just want to be fancy, they call it k. That's still your slope, that's still your rise over your run. And that's what we want to look at when we're trying to identify direct variation examples. With this little walkthrough setup, let me zoom in and move this where I need it to be. Move instead of erase, Mr. Block. Good job. Zoom in. Zoom in. Okay. So because we have that y equals mx, that's what we're looking for. So as a result of that is, if you have anything else extra after that, then you know automatically it's a fail. So for example, if we're looking down here, we have that -1. That's a b. Is there a b up here for what we're looking for? No, so that's a fail. It's not a direct variation. Over here, we have a 1 again. That's going to be a b if we do a little bit of algebra. Is that what we want? Is that what we want? No, it's a fail. So finding a non-direct variation is actually kind of simple. The next question is direct variation. If we can get a y and an x. And you see we have a y and an x, and we have a y and an x over here. The question then becomes, how do we get it to look like y equals mx? Well, the same way you always do. You get y by itself. So if I look at this, I'm going to divide by 8, divide by 8. What does that leave me with? Y equals 5/8 x. Is that the format we're looking for? Y equals number x, y equals number x? Yes, it is. This is direct variation. And what's your k? Ooh, boy, I don't know. There are so many options to choose. Yeah, it's just the number that you have in front of the x. Over here, same deal. So divide by 16, divide by 16, y equals 2 over 16x. Now, if you're really good at this, your spidey senses are tingling, because you know how it says simplest form? That's a not subtle hint that sometimes these fractions can be reduced. 2 and 16 are both even numbers. That means we can divide by 2, divide by 2. So y equals 1/8 x. So yes, it's direct variation, and 1/8 is the only number you have, so that's what goes in your k, your constant. Another couple of problems, just to make sure, because now I don't have my little walkthrough in front of me, and I want to see if I can do this code. I have a y, I have an x, I have a y, I have an x, but I have that extra number, so this makes this not a direct variation. Here, I have a y, I have an x, I have that extra number. That means this is not direct variation. I have a y, I have an x. So we know these two are direct variations. Very good. Now we just got to figure out, okay, let's put in some effort, do a tiny bit of algebra to figure out what our k, our slope is. So divide by 8, divide by 8, y equals 2x, so therefore our constant is 2. Let's see here. I need to get y by itself, so it's not the 5 I'm moving, it's the 4. So divide by -4, divide by -4. What am I left with? Y equals -5/4 x. Okay, so far so good. And that's my number, 5/4. There. Okay, so that's looking actually pretty good so far. We can identify these at a glance, and then in the span of one step of math, we can actually do the solving. So next one, identifying it from identifying it from ordered pairs. This one is the exact same idea. It can be a little bit trickier, but let's do some poking. What we're looking to do, that k, you know how it was like 2/1 or 5/8? Since those numbers, those are fractions, right? So that is rise over run over run. So when we're looking at a coordinate plane, brush tool, when we're looking at a coordinate plane, I'll have to draw it from scratch now. There we go. What axis is taking care of our rise? That's our y-axis. So this is, computer, what are you doing? So this is in fact going to be our y over our x. That's what we're trying to do here. Knowing then if it's going to be y over x, that's the most salient point of information. When they give us a table of ordered pairs, what we're doing is we're going to take every single one of them and do y divided by x. And if we do it right, if this is in fact direct variation, we're going to get the same number every way. So for example, if we have 5 over negative 10, that equals, let's see here, let's use my magic math brain, -1/2. Let's see here, this is y over x, so it will be -1/2. Well, that's -1/2. They're matching so far. Next, I have -2/4. That simplifies to -1/2. Same number, same number, same number. So this is direct variation, and the equation is 1/2 x. Because again, that's your k, your constant, your slope, your rise over your run. That's what they're looking for you to do. Over here, let's see here, 5/4. Well, that's already in reduced form. We know what that is. We have we have, computer. Over here, we have 10/4. 10/4, those are both even numbers, so divide by 2, divide by 2. Oh, we have 5/4 over here, and we have 5/2 over here. They're not the same number, therefore this is not direct variation. Skip down a little bit. Let's see here. We have 5/4 again, and oh God save me, they gave me decimals. Whatever shall I do? It's not like we don't have calculators or anything. So let's find out. 6.25 divided by 5. Does that get us 5/4? Yes, it does. So this is also 5/4. Or if you prefer, it's 1.25. Next one, we have 8.75 divided by 7. Do we get the same number? We do. Okay, so this is also 5/4. So this is direct variation, y equals 5/4 x. All right, let's see here. We have 5/2, okay. We have 10/4, those are both even numbers, so that's 5/2, so far so good. Then we have 20/8. That's a little bit tricky, but they are both divisible by 4, so divide by 4, divide by 4, 5/2. This is direct variation, y equals 5/2x. So don't be afraid for this one to use a calculator to find out whether or not you're getting the same number, and that's ultimately the point. You're doing your division, and then you're finding out, okay, is it the same number? Is it the same number? Is it the same number? So far, so good. Next up, can I zoom out a little bit? So I can get these both in one go. All right, there we go. This one, since we now know, and I'll rewrite it again, if the whole point is y equals mx. That's the whole point, and we know that the m is going to be your change in y over your change in x. That's what we're looking for. So since we're told all of this, then we have everything we need. There's my y, there's my x. So therefore y equals, what's our y? 4/20 x. And they do want you to write it in simplest form, so that becomes y over 1/5 x. That's all they're looking for here. Once they give you these numbers, it doesn't even require that much thought in order to make your equations. Then the next question actually requires, well, only half a thought. They're telling you on a silver platter that x is 9. Well, gee, if I have an x and I know what the number is, what do? I substitute in. So what is 1/5 times 9? And if you're fuzzy on this, remember it's 9 over 1. And we're going to multiply across. 1 times 9 is 9. 5 times 1 is 5. There's your answer. And suddenly this doesn't look so hard. Next one, we're told our y, we're told our x. So y equals -8 over -2x. Simplify. Double negative is a positive. 8 divided by 2 is, in fact, 4x. Lag. Okay, now we're going to plug it in for when x is 5. So y equals 4 times 5. What is our answer going to be over here? 20. So far, so good. A couple more examples. Let's see here. We have y equals, what's our y, what's our x? We have -18 over 3x. That simplifies to y equals -6x. And you're starting to see that sometimes they're nice to you. Not everything is going to be some gut-reducing fraction. We can breathe with this. So y equals -6 times 2, because that's the x that they give us. So then y equals -12. There's our solution. Last one. Oh, computer. Last one. Let's see here. Y equals, what's our y, what's our x? So it's going to be 2 over 16x. We can do that. That can be reduced because both of those are even numbers. So divide by 2, y equals 1/8 x. All right, not so bad. Then we're plugging it in when x equals 7. So we have 1/8, y equals 1/8 times 7 over 1. Multiply across. 1 times 7 is 7. 8 times 1 is 8. And our final answer is 7/8. That's 3 out of 4 topics. And so far, the math has been doing pretty nice to us. Now we get to la pièce de résistance, everybody's favorite 2-word combination. Word problems. I know. The horror. But this is where the love part of the love-hate relationship with the software comes into play. Because this is a word problem, the computer can't change the wording all that much. It's a little fixed. And we can actually kind of trick the system and turn that into our advantage. So you see the word varies directly. That's our key right there. Because you have y equals something x, right? Let me rewrite that. Let me get my keywords here first. I'm doing this on the wrong layer. All right, I think we're all caught up. So here's the thing where the word problems start to come in handy. When you have something varies directly with something, whatever that first word they give you is going to be your y. Whatever that second word they give you is going to be your x. So in this case, the distance, lag, and varies directly with the amount of gas, which is going to be gas. So now that we know that, we have the things that we need. So what do we have? We have 17 gallons and 459 miles. So 459 equals 17 times our constant, because that's what we're looking for. This particular problem is done in 2 parts. Now, I'm good, but I'm not that good. I have a guess, but I want to see what 459 divided by 17 is. 459 divided by 17 is 20. Whoa, I wasn't even close. 27. So K equals 27. Now notice it's not asking for the constant of proportionality. It gives you instead yet another number, 23 gallons. So that gallons of gasoline, is that my y or is that my x? It's my x. So y, computer, y equals 27 times, how many gallons? 23. 23. That's what we're looking to do. So what is 27 times 23? 27 times 23 equals 621 miles. 621 miles. Okay, another one. We have our little cheat sheet, so we know whatever they give us varies directly. Something varies directly, so this is your y, and this is your x. Okay, so this is a little bit, you can see the wording here is a little bit more awkward, but force acting on an object, so this is going to be force, varies directly with acceleration. Acceleration. Now that doesn't actually help me because I don't know what force and acceleration actually mean. Like, what? I'm not a science person. I'm sorry, Mr. Milligan. So I have to look. Force is in newtons. Okay, so that's in newtons, and acceleration is 10 meters per second squared. Okay, now I'm all set. So force is 50 equals, what's our meters per second? 10 times our constant. So divide by 10, K equals 5. And then what do they tell us? 35 newtons. Okay, newtons is which one? This is our y. So 35 equals 5 times our x. Divide by 5, x equals 7 meters per second squared. That's what we're looking for here. Okay, one more, and then I'll send you off into the wilds, and we'll have one more video that finishes up goal 3. So, scroll, computer. There we go. All right, so it is something varies directly with something. Okay, so what do we have? We have distance again. And then with gallons of gasoline. Oh, the lag. Okay, so let's see here. 230 miles, that's a distance, which means that's our y. So 230 equals our constant times what's our gallons? 10. So divide by 10, K equals 23. Okay, so far so good. Next, let's see here. The next number they give us, the 12 gallons, is that our x or our y? Gallons is our x, so that's going to be times 12, all right? What is 23 times 12? I don't know that off the top of my head. So 23 times 12 is 276. Y equals 276. All right. My computer is overclocking really bad. You can tell because of the lag. We will call it quits for now. But what this means now is you only have one family left in order to be ready for the objective knowledge check and the DSA. We're almost there, ladies and gentlemen. I humbly wish you good luck. When I see you in the next video, we will take care of the last of this. As always, stay happy, stay healthy, stay safe.